Welcome to LabMIS.com in our lab video series on Cisco ISE 3.0. This is Mehta, your instructor for this video series. For a complete list of ISE video, you can visit our website under the security section. There you can also sign up for our newsletters to receive the latest video updates. One of the great features that have been around is the built-in certificate authority function. Even if you don't plan to use ISE internal CA to issue certificate to endpoints or other system, ISE still uses it to secure internal communication, so it is not a bad idea to understand how ISE internal CA operates. So in the first half of this video, we will review ISE internal CA, and then for the second half, we will take a look at the new pxGrid section of the GUI and do some pxGrid integration with the Cisco DNAC and the 5-Power Management Center. For our lab setup, we have a currently 2-node deployment of ISE in distributed deployment with ISE 1 and ISE 2 running version 3.0 with ISE 1 having IP address of 172.1632.102 and ISE 2 is .103. This is something that we have built in the last video. On that same VLAN, which is our server VLAN, VLAN 32, we have a Windows 2019 domain controller, DNS, and certificate authority server at the IP of .40. Because we're going to be doing some integration with DNAC and FMC, we have those servers on that same VLAN with the DNAC having the IP of 32.111 and the FMC with the IP of .107. All of these are sitting on our core switch 1 that provides access to the internet if needed. First, we are going to take a look at the ISE internal CA functionality, and there are two models when using ISE internal CA. The first, which is the default mode, and that is using ISE as the root CA. If you look at this diagram right here, the way that it works are, let me grab a pencil to help me explain this. So ISE has a self-signed root certificate right here. This root certificate is used to issue what's so-called a node certificate that is going to be on the primary and the secondary admin node. So it will go that way and that way, issuing and sign the node certificate. The primary admin node in turn issue two more certificates, and they are known as endpoint sub CA and OCSP. And this is going to be sitting on the PSN. Finally, the PSN used the endpoint sub CA to sign any certificate that requires, right? Whether it's for the client perspective or whatever certificate that you enroll through the certificate web enrollment. Right, so that goes to the endpoint. And that is basically the default ISE internal CA certificate hierarchy. So the benefit of doing this is that everything is pretty much self-contained without having any kind of dependency on external certificate authority server. So you being the ISE administrator have a complete control of the PKI. The downside of this is you have to make sure that the other system, that the endpoint or whoever that has received their certificate signed by our PKI has to trust the ISE root CA right here, right? Because by default, nobody else outside the little system knows about the ISE internal CA. Right, but that's only when you want to use that certificate to authenticate to external system. But if everything stays within ISE, so meaning that the endpoint use certificate to authenticate with ISE, which obviously already know about the root CA, then you would have the problem. That's the first method or mode. The second mode that you have available is also to roll ISE up to your internal CA or enterprise CA. In this case, this is what we have right here. Everything is the same as before, except for that ISE root CA certificate becomes an intermediate certificate signed by your enterprise CA. Right, so you have this extra level of certificate hierarchy right here. Otherwise, everything else from that point down remains the same. It's just that when you look at the ISE certificate or internal CA certificate, is no longer going to be a self-sign, right? It's going to be signed by your enterprise root CA. The benefit of this obviously is that certificate issued by ISE will be automatically trusted by other system that's already trusted your enterprise root CA. Okay, so if you have an external system right here that your endpoint that receives a certificate needs to authenticate, if that guy's already trust your enterprise root CA, it will automatically trust that endpoint. But the downside of that is you need to work with your certificate authority team or PKI team to get this set up. And that's after having to convince them to give the ICE certificate signing capability, which some organization may be reluctant to do so, right? Because in order for ICE to be able to sign the certificate, it has to have the correct signing privilege. Now let's jump into our ICE GUI and take a look what it looks like on the GUI. Let me bring up the RDP session. Here's the default dashboard on ICE. So we're going to go ahead and jump into administration and certificate. We have already spent some time in the past videos looking at the top half, which is around ICE certificate management. And we went through, issuing the CSR and then have it signed, the certificate being the wildcard certificate. Now we're going to redirect our attention to our certificate authority section, which is in the bottom half of the page. Let's take a look and see what kind of menus we have available. First is the overview menu, and this is basically the summary of certificate that have been issued or revoked by the system. You get the summary counts on this page. Issue certificate is just a list of all the certificate has been issued by the internal CA, including its validity and status, and who has been issued to. Right, friendly name, device, unique ID, certificate authority, certificate. So let's spend some time and see how this certificate reflects the hierarchy that we just reviewed. So to kind of help myself explaining this, let me go ahead and put this on Microsoft Paint so I can start drawing on it. Make it a little bit bigger. Go. So if you take a look at this guy right here, everything starts off at, and it's kind of easy to identify as well based on the assigned number to the certificate, especially if it's a fresh install like ours. Starting with number 1 right here. Change the color and the size. There you go. So if you look at this, this is basically the default self-signed root certificate. As you can see that it's LM ICE 1 signing LM ICE 1, so that's obviously a self-signed certificate, and that's basically at the top of the hierarchy, so it'll be this guy right here. And then we said that this guy, in turns, issue the node certificate, so let's find node certificate, which is this guy right here. Then you can see that the root is actually signing the node, so it goes like this, which is this level of hierarchy. And then at the third level, you've got the node certificate issuing the endpoint sub CA. And you can tell by the name, this is endpoint sub CA, as well as the OCSP responder. So that guy in turns sign this guy and this guy, right? Which basically completes the hierarchy that we just talked about. What happens to the secondary node, we can also take a look as well. Now that we have it registered, you can also view what's going on at the bottom. Let me do the same thing real quick. Grab that. Then I'm just going to paste that and do the same thing. Looks like I didn't capture the whole thing. My bad. Actually, that's it. There's only 3 certificate. All right, so again, the root itself, as you can see, there's no self-sign here because the root is located or stored on the primary admin only. What you see is the node certificate, which is number 5. Again, it goes up in the number because 1 through 4 is on ICE 1, and then 5, 6, 7 is on ICE 2. So you have this guy right here. Right, being signed by ICE 1. So everything rolls up to the same root. So this guy also rolls up to that, which means that it doesn't matter if the certificate is being signed by the left-hand side branch or the right-hand side, everything will be trusted as long as the root CA or ICE is trusted. And same deal, we've got the endpoint sub CA right here. being signed by its local node. And then the OCSP, right? So you get this as well as this. So what is not being shown in the diagram is actually the PSN functionality local to the secondary node right here and here that's being signed like that. When we look at the certificate chain on the issue certificate, which we'll get to see later on in this video, you'll be seeing something like this. Okay, and then if you go with the option 2, which is using your enterprise PKI as your root CA and then the ICE being the intermediate, then you get that extra level right. All right, so hopefully that clarifies the whole thing. Next is the internal CA setting, and this gives you ability to disable internal CA, but by default they are enabled. As you can see, the green check marks on both ICE 1 and 2, but for whatever reason you don't plan to use the internal CA, although I don't recommend turning it off anyway because it's used by internal ICE functionality. Just leave it on, right? Certificate templates, these defines how the client certificates will be created. It contains the certificate attributes that's usually found in the certificate signing request. And by default, ICE comes with 3 certificate templates. One for the CA service, the second is for EAP authentication, and the third is for the pxGrid certificate. So there are 3 of those. If you need more, just add it yourself. The last menu option here is external CA setting. And this is the external certificate authority config if you don't want to use ICE internal CA. And the way that ICE communicate with the external CA to make a certificate request is through SCEP. Right, so basically you're adding a SCEP server in this section right here. First, we are going to demonstrate the first method, which is using the default ICE internal or being the root CA. There isn't actually anything that you need to do because this is enabled by default. What I'm going to do here is to show you how to replace the certificate chain, and you might need to do that at some point. And the way to do that is you go under certificate management. It's kind of weird that you actually hop back to the top section. You go under certificate signing request, generate certificate signing request, and what you do, actually we've been here before when we generate CSR for our wildcard certificate and we chose mount to use back then. But if you look at the option, we have 2 options specific to ICE internal CA. One is to create ICE as root, and the second is to have ICE as an intermediate CA. We're going to select ICE being root, and what this guy's going to do is they're going to replace the ICE internal certificate chain, and we'll see in a second here. Like I said, there might be a time where you need to do this. There was actually a bug that requires you to replace or renew the entire certificate chain to fix some ICE messaging services after the upgrade. So there could be a reason like that where you want to do this. Go ahead and replace iRoot certificate CA chain. There you go. We've got a little pop-up message saying that there might be some delay of the certificate appearing, I guess. So refresh the table. If it doesn't show up, click OK. And we're immediately taken back to the certificate authority certificate section. One thing that you can immediately notice is that if you look at the quantity of the certificate, before we had 4 certificate, if you remember, now we end up with 8. If you look at the number on the certificate, we've got, in addition to 1, 2, 3, 4, now we've had 8, 9, 10, and 11. 8 being the brand new self-signed ICE CA root certificate. Right? 9 is the node CA, 10 and 11 are the endpoint subordinate CA and the OCSP responder. So basically, ICE completely switched over from the first 4 certificate now to the bottom 4. If you look at the LM ICE 2, we still have the 5, 6, 7. Maybe it's still not refreshed at this point. Let's see if I can refresh that. There you go. So exact same thing happened to ICE 2 before we had 3 certificate. Now we end up with 6. Right, and that's because the certificate number 12, 13, and 14, 12 now is being signed by the new root CA certificate on ICE 1, and then the 12 in turn signs the 13 and the 14. One thing to notice is that the old certificates are not deleted from the system automatically, since there might still be the client in your network with the certificate signed by the OCA that you want to continue to trust. Okay, so before you come in here and start deleting the old certificate, make sure that you are 100% certain that you still don't have any old clients that's being signed by the old certificate chain. Otherwise, this client would not be able to authenticate. Now let's look into the second option, which is having ICE works as an intermediate CA. What we're going to do here, we're still going to need to replace the whole certificate chain because the current chain is being signed by ICE internal CA or root CA. So now we're going to go back as we saw the second option, which is ICE intermediate CA right here. So I'm going to go ahead and click generate. All right, so what this does is it's going to generate CSR for, clean this up, ICE internal CA, which needs to be signed by the external CA. In our case, it's the enterprise CA. Click OK. Here's our CSR. Go ahead and view and get the content. Let me copy that. Let me go to the localhost CA. Because our Windows domain controller here also acts as the certificate authority server, click request certificate, submit base 64, and then paste the content right there. The template that we're going to use needs to have the signing capability. So the one we're going to use here is subordinate certificate authority. If you use anything else, it's not going to work. Right? It needs a special usage in there. For cert signing, go ahead, click submit, download, and I'm going to save that in the desktop and call this ICE sub CA. And we can take a look. You can see it's being issued by LM root CA to certificate services intermediate CA LM ICE 1. And most importantly, if you look at the key usage, right there, you can see how it has the certificate signing key usage in there. Actually, I also want to show you the cert chain right here. Yep, definitely roll up to the LM root CA now. Now let's go back to ICE and perform certificate binding. It's going to be ICE sub CA. The name, we'll call this LM intermediate CA. So this is going to take a couple seconds as well, because what's going to happen is it's going to replace again the entire certificate chain now, so that process takes time. Looks like that is done. We'll go back to the CA certificates. And as you might have guessed, we've got 3 additional certificates right here. Actually, it might not be quite done because I don't see the OCSP, so let me refresh that. I wonder if it's still generating that. But anyway, let's take a look at what we have. I think we expect 4, not 3. So the new numbers are 15, 16, and 17 that we're seeing so far. The 15, what used to be a self-sign ICE internal CA certificate, now it's actually being signed by the LM root CA, and that's the cert that we generated and signed just now, right? And imported, I should say also. Right, and then that certificate in turn signed the node CA just like before, so nothing changed, like I said, from this point. All right, what we just did was this. Now the new intermediate ICA is signing the node CA, and then that node CA continues to sign the endpoint subordinate CA. Though I'm not sure why I'm not seeing the OCSP one though. I would expect the 18 will be in there. Let's take a look at ICE 2. So ICE 2 has got the 19, 20, and 21, right? Because the ICE 2 node CA now is being signed by the new intermediate CA cert, and then the node CA and ICE 2 signed the subordinate and OCSP. Yep, I think we're missing 18 for some reason over here. Not sure why, but as you can see on ICE 2, you get the OCSP responder, but for some reason it doesn't show unless it's further up. Oh, there you go. Actually, I missed it. Somehow I put it towards the top. I thought it would be in sequence or something, but yeah, right there. So we got our 18 right there with the OCSP. Right now that we have a complete functioning ICE internal PKI with the intermediate CA functionality running on ICE being signed by Enterprise Root CA to make sure that you are able to recover from any kind of catastrophe where you have to do a fresh install on ICE. Right, we need to back up the ICE root or intermediate certificate as they are not backed up with the schedule config backup if you have that set up. Right, this way, your recover ICE deployment continues to trust the cert that were issued before the failure and continues to trust all the certificate has been issued to the endpoints, right? So they won't fail authentication after you recovered the environment. To perform the backup of the internal CA cert, first you need to create a repository where you're going to export that certificate or copy the certificate to. So we go to maintenance, repository. We're going to use our Windows 2019, which is the machine we're on right here. It's supposed to be running. There you go. Let me bring up the FileZilla. FTP server. Let me make sure that it's pointing to the desktop. Yep, it's pointing to the desktop right now, and I have a username, password, Cisco set up for that. So I'm going to hit and call this one FTP. Server name 32.40. Root path Cisco. Okay, submit. We got the server running. Let's go ahead and SSH into ICE number 1. Let's check if our FTP repository is working. Okay, we can see the content on our desktop, and we can see the successful connection right there as well. So, yep, ICE can access the FTP server. Then you issue the command application, configure ICE. It will give you a bunch of options, but the one that we need, if you read through this, is export internal CA store. And that is number 7. And just FYI, to import or recover from a fresh install, you will use option number 8, which is import. Here we want the 7. Okay, it's going to take a little bit of time. We can monitor this. Just FYI, only the 4 active certificate that we saw will be exported with this process, right? The both certs and key pairs. Any older certificate needs to be exported individually from the web. Yep, it's going to be FTP for repository. Then you have to enter the encryption key. Got a little warning. I don't think there's anything to be concerned about. Yep, it's doing its thing right there. And I'm waiting for the file to be transferred. Looks like that's completed. Did we get a file? If it says successful, you can see the list of the certificate. Did we get a file on the desktop by any chance? Yep, I believe it's this guy right there. Was that the name? Yep, there we go. ICE CA key pair on ICE 1. For some reason, it actually didn't go through for ICE number 2. So that's something we have to look into right there. But anyway, you get the process. So we get the key pair for ICE 1. Yeah, I think we saw a bunch of errors on the top as well. Not sure if this is related to this new version or not. But anyway, that's the process. So make sure you do that as soon as you get everything set up. So go ahead and exit that. Before moving on to the next part of the lab, which is pxGrid, what I'm going to do here, we're not going to move forward with 2 nodes just to remove some complexity from our lab. So what I'm going to do is to deregister ICE2. Yeah, I want to show you what happened in the internal ICE CA or PKI when you have 2 nodes or multiple ICE nodes, but moving forward, we're just going to use ICE1 in our lab. So I'm going to go ahead and deregister. So this is the process of deregistering ICE from your deployment. Pretty straightforward. Come to this deploy node page, select the node that you want to remove from your deployment, and then you hit deregistered, confirm, and it's going to take a little bit of time to remove that. Basically, that's going to convert this particular node back to a standalone node. So again, regain the full access to that node.